Okay, this is the P3 paper from October 2022. It's question number 3. This is going to be a differentiation question. We are asked to find the exact coordinates of A, and A is a maximum point. We find maximums by differentiating and putting equal to 0. Looking at our function as being that, the way that we're going to differentiate this then is going to be a product, a U and a V there. So let's do that. We'll worry about the second part once we've done the first part. So part A, we said our function was given by fx is equal to x minus 2 squared e to the 3x. So as I said, I'm going to let u be equal to, in this case, x minus 2 all squared, and v be equal to e to the 3x. So when we're differentiating both of those, it's chain rule, but very simple chain rule. Du by dx is something squared is 2 lots of the something, multiplied by the differential of what's inside the bracket, but the differential of x minus 2 is 1. So you can multiply by 1 if you want to. I'm just going to leave it like that. dv by dx, again, the differential of e to the 3x is e to the 3x multiplied by the differential of what's up there, so multiplied by 3. So most of us would be able to do that without too much of a bother, 3e to the 3x. Once we've got that then, f dash x, using the product rule, is u dv by dx plus v du by dx. So u dv by dx is those two. I'm going to multiply that out then. I'm going to call that 3e to the 3x, x minus 2 squared, and v du by dx is the other two. So that's going to be plus, I'm going to put 2e to the 3x to get 2e to the 3x, x minus 2. Just compare that with what we've got up there. I'll put the 2 at the front when we're actually looking at that. Sometimes I'm just asked to find f dash x, but in this particular case, I'm actually trying to find the coordinates of A, and A is a maximum turning point. So I can say at maximum turning point, f dash x is equal to 0. So that means I'm going to get that 3e to the 3x, x minus 2 squared, plus 2e to the 3x, x minus 2 is equal to 0. Now, if you haven't done any of these before, then this looks quite difficult. If you have done some, you can see, no, we normally have a fairly straightforward thing to do here. In this particular case, I'm just going to factorize. What can I take out? I can take out e to the 3x, and I can take out x minus 2. I can factorize. That's going to leave me, from that first term, the 3 is left, and one of the x minus 2's, and in the second term, just the 2 is left. Now, when we're looking at this then, if we tidy up what's inside the square bracket, I'm going to get e to the 3x, x minus 2, and that all tidied up to 3x minus 4 is equal to 0. So first of all, this is e to the 3x equals 0, x minus 2 equals 0, or 3x minus 4 equals 0. Well, e to the 3x equals 0, we should know there's no solutions to that. Remember what the graph of e to the x looks like. It looks like that. There's an asymptote here. So that's certainly not going to be a solution. So I get the possibilities of x equals 2, or x equals 4 over 3 as my two answers. And then if we go back here, we can see that x equals 2 is obviously the minimum one there. So x equals 4 over 3 must be that one there. And 4 over 3 is less than 2. But so because of that, we can say already have this, or can already see this from the information in the graph. So x equals 4 over 3 is the one that I'm looking for. And remember, I'm actually finding what f of 4 over 3 is. So stick that into our function. 4 over 3 minus 2 squared times e to the 4 there. Tidying that up, that comes out to be 4 over 9th e to the 4. So A is actually the point 4 over 3, 4e to the 4 over 9. And it's okay to, it probably says in the question to have it as an exact value. Yeah, find the exact coordinates of that. So be happy, but be quite contented with the fact that we've got this written down in terms of, you know, that looks a bit weird if you've not done any past papers, but if you have, then yeah, that's absolutely fine. I've got no problems with having the answer as that. Part B, what does part B say? So part B says, given that the equation fx equals k, where k is a constant, has at least 2 distinct roots, can we work out the range of things that k could be? Okay, so let's just explain that first of all. Let's get rid of this stuff off the graph because I'm going to use it. If we're trying to find where fx equals k, there's a different colour here, k is basically represented by a line going straight across, y equals 4, y equals 2, fx equals 2, something like that. So fx equals k is just this line here, fx equals k, and when I say this line here, I mean this line can be all the way up there, keep coming down, can hit here, can be any of these values, and can even be down here. But because I want the situation where it has at least 2 distinct roots, if I just put it up there, at the moment that's only got 1 distinct root. It only hits the curve once. So if I do now bring this down to, oops, excuse me, just bear with me with my iPad. If I do now bring that down to that point, at the point where it's actually hitting A there, now it's got exactly 2 roots, hasn't it? Because it's hitting that maximum points. And we know that that is given by what we just found as our answer. That is given by, what do we have for the y value? 4e to the 4 over 9. So I can even put this on my graph just for a second. 4e to the 4 over 9 is that value there. And then as I move this down, that's 2 roots. As I now move this down, 3 roots, but it says at least 2. So all the way down here, yeah, there's more than 2 roots, there's 3 roots, keep going, keep going, keep going, keep going. Now at some stage here, and actually when we hit this asymptote then, that's going to be the other limit. So if I actually copy that graph, that line here. So from there all the way down to that point there, which is where fx equals 0, in between those two then, this is the range of values that k can be. Now, do we want to include them or not, where it has at least 2 distinct roots? So it's going to be, when I'm looking at that, in order for it to have at least 2 distinct roots, it's got to be, so it's only a 1 mark answer here in terms of, let's just change the colour of my my pen here. K can be less than or equal to 4e to the 4 over 9, but then if it actually hits the asymptote down here at the bottom, at that point there, this one will never touch, but it's an asymptote, so we can't include that one there. So actually just make sure you're happy with that last little bit. It's a little bit tricky just to do that part there, that it's going to be inclusive of that one, but not of that one. That's quite tough, that last part. You might need to read that through a couple of times. But apart from that, that's the rest of the question done. And hopefully all of the rest of the part of that one actually makes sense. That last bit, just keep having a look at it.